Zoom recording. All right, so we ended up being cut short. We don't pay bills with Zoom, so it is what it is. Time difference. We defined, now we are calculating. I described what intermodal dissipation is. It is pulse broadening. And I described how it came to be, how it happens, different modes, different parts, different TOAs. Therefore, we have pulse broadening. Now I want to calculate. We want to calculate. How do you calculate that? Derivation of that calculation, it was done in the videos where we calculated the time difference. The time difference between the ray which arrives first and the ray which arrives last. What is the time difference between those two? That is how we calculated pulse broadening. And we ended up with a formula like this. L, which is the length of the optical fiber, N1 squared, which is the refractive index of the core. It ended up with something like this, which can be simplified to L N1 over C, N1 minus N1 minus N2 over, yes, over N2. That is the formula we have. You need to be very conscious on my units. I think we have a session, Pachawaker, using some of these formulas, and let you see the importance of understanding these units. Importance of understanding these units. All right, so you can use that formula. You'll be given the length of the optical fiber, the refractive index of the core and cladding. You know the speed of light. You know. What is the speed of light?
3.8 times 10 to the 3 times 10 to the power 3 times 10 to the power 8.
Well, voila, you need to know this.
Yes.
This is what meters per second. I think we are going to be using the one in kilometers per second. I know for sure, which is 3 10 to the power 5. We are going to be using this one. My units, you need to be very conscious on my units and understand this one. Kilometers per second to the power 5. You see importance of this as we start making my calculations. Or if you've already made my calculations, you are already seeing the importance of that. Right. Why do we require cladding? At this point, the question that I took up on the last time, why do we require cladding on Oyster and the protection? It was answered exactly at this point in the video. Why do we require cladding? Assignment, why do we require cladding? I think I gave this one in the exam. And so my videos. Why do we require cladding? Anyone other explain that?
You say if the time duration is small, it means the bandwidth will be very big. For communication purposes, bandwidth should be very high.
All right, bandwidth should be high. What does time difference?
The time difference, delta T is equals to Ln1 over Cn2.
No. Delta T can be high. What happens to the bandwidth?
The bandwidth is very small.
Okay, so here we need delta T to be very small so that we have a large bandwidth. Right, continue.
And you said the time difference should be very, very low. Then delta T is equals to Ln1 over Cn2. open bracket N1 minus N2. Then you said for high bandwidth, the time duration should be very small, delta T, open bracket N1 minus N2.
So delta T N1 minus N2, like this.
Yes.
Yeah.
Yeah, that's what I know.
Okay, thank you very much. Who is that? Yeah, Chief.
Chief.
Right. Chief. That is something. All right. Why do we require cladding? All right. As he said, for communication purposes, our bandwidth should be high. This is the starting point. If our bandwidth is to be high, then it means the time difference, the width, the discussing here bandwidth and width. The width should be very small. The width of the pulse should be very small. From definition, we want to find what is the relationship between the width and the refractive indices. How do we do that? First step from definition is we can remove N2 over N1. Why? Because you see that N1 is approximately equal to N2. You see as you make my calculations, N1 in 1.45, N2 in 1.44. They are very close to each other. You go ahead 1.46, you go ahead 1.45, which is not the case for all my optical fibers, but they are very close to each other. What does that mean? It means N1 over N2 is approximately equal to 1 because they are almost the same. It means by equation here I can remove N2 over N1, which is equal to 1. Now our time difference will depend on L over C N1 minus N2. What do we know? If we keep L and C as constants, C is already constant, speed of light doesn't change. The length of your optical fiber, if you don't change it, then the time duration will depend on N1 minus N2. Time duration to be small. Now, Tapana, let's say it will vary with this. For time duration to be small, so that our bandwidth, so that we allow our bandwidth to be big, this value here should be small. If we want this value to be small, it means this value here, N2, should be small. Let me do this. Should be kept at a minimum. If it is kept at a minimum, it means we no longer have cladding. It is now equal to 1, which is the minimum value. It means we no longer have cladding. But however, cladding is perform optical fibers. Why? Do but that will be the answer. Why do we need cladding? Right. For high numerical apertures, numerical aperture, light accepting efficiency. For high numerical apertures, however, N1 minus N2 should be very big. The pure formula is numerical aperture. Numerical aperture.
Root of N1 squared, N1 squared.
Minus N2 squared. And
minus N2 squared. Yes.
For high numerical aperture, logic tells me this value should be very big. Okay? If I want a higher light accepting efficiency, this value should be very big. I think you say it up. But if I want a low time difference, here I need high. If I want a low time difference, N1 minus N2 should be small. If I want a high NA, N1 minus N2 should be very big. Which is more important? a larger light accepting efficiency or a smaller pulse width? Which one is more important? No one to answer that. All right, we have two more situations. NA, light accepting efficiency, the ability of optical fiber to capture light should be very big. It means N1 minus N2 should be very big. At the same time, the time difference should be very small, which will lead us to N minus N2, which should be small. Now, my engineers, what they did, tikada cautious bandwidth. It means it should decrease at this value, and our time difference will be small, and we have high bandwidth per optical fibers here. But what will those high bandwidths mean if you don't have efficiency per accept the light? But upinda optical fiber up. Light racho kana risiri kupinda. What then do you need the high bandwidth for? Okay, that's where the compromise was made. We need cladding. We need cladding. Right? Tikabisa cladding up. Let me see. Could E increase E? E no fanata small. Could E decrease E? Up N2 small is goes to 1 panap N2 should be big. So the compromise was made. E do without cladding E. Without cladding. Right. So canatisina cladding. It means we have a very high numerical aperture. A light red or no pin does an optical fiber. But bandwidth dololo. Bandwidth in dololo. Because N2 edu increase over highest, which is not 1. Tika increase kuno bandwidth increase N2 aka increase sterek bandwidth yedu yaku increase, but kuno numerical aperture dololo. So the compromise, that is the reason why we use cladding, because of the compromise between these two, the numerical aperture and why we use cladding for compromise between the bandwidth and the numerical aperture. Right, typical question here, or explainer, in simple terms. Right, another thing I can add, kana when you explainer, I would prefer you put in point form. Bandwidth, determine when N2 kana kwira kana takadzika. Numerical aperture, determine when N2 kana kwira. So it means kana zadaiso, and lastly zadaiso those scenario. I prefer you answering questions like this than putting a paragraph. Small, than putting a whole paragraph. I hope you are getting this. These are examination tips specifically for my courses. I prefer point form because per point, each point then per paragraph, I rarely read paragraphs. I think numbers down. I rarely read them. So put my point forms, put equations, put diagrams. Never put my paragraphs. No. My exam. Okay. The question no I can describe what this intermodal dispersion is. We're not going to always run what's in your app, but it's all for it. Point form. Different modes, different parts, different chakadaro, diagram, rago, equation if needed. You are done. And that is the reason why we require cladding. It's sort of a compromise between bandwidth edu and numerical aperture. Then lastly, for today's sessions, I'll talk of the bit rate length product. Bit rate length product. What is that? Banana question. Yes.
But now you feel it to interrupt here.
Banana feel it first of all at Batsir. No one sama Marxist participate chief is I don't moving in the right direction. I don't pay this. This is where the compromise is. You can see the diagram here. This is where the diagram is. Where the compromise is, I mean. Abana. Okay. I'll repeat. All right. The internet unit 2 is involved. Bandwidth and numerical aperture here. Bandwidth yangu inofana iri very high. Numerical aperture yangu inofana iri very high. Chinated bandwidth yangu ite very high. Time difference is very low. Tazona kupi tazona by definition. Your time difference. Where is the definition? Here. Inofana ita low ish. Right. Could the time difference is a low? Right, this one. Could the time difference is a low? This difference here, Raman refractive index, N1 minus N2 should be low. Those I'm going to explain. Pesa. Where are we? Where are we? Here. Panasakanda Gomera. Time difference. Apa batera. Manandi from the question. What about but time difference here it varies with N1 minus N2. Mabata. Right. And what about right? So this value should be very low. Could time difference here it is very low. Could be with it is very high. Okay. For numerical aperture, from definition, could the numerical aperture it is high? This difference here should be big. Because definition in numerical aperture is equal to root N1 squared minus N2 squared. I tried finding how they came about kupapana squared uyu kutoka pa difference e, but I couldn't find a simpler way to explain that. But logic, numbers this value should be very big, or let me say this value N1 squared should be very big. But for explanation, in one sense, I needed this to is here and here. Almost the same, not the same, almost. So we have two more scenarios about a bandwidth near numerical aperture. This is often very high, but the generator is high is also by definition, this difference should be high. However, this difference should be low. Right. Difference E very low is. What does that mean for N2? It means N2 should be high. Could N2 could it N1 minus N2 either low? Let's say 1.45 the N1 minus N2 another 1, then 0.45 difference. N2 another 1.4, then 0.05. 0.05 is less than 0.45. It means this value should increase. 1.4. Logic. However, value ya N2 increase. How does it affect PANAP? Value N2 increase. N1 will do 1.45. N2 will do 1.4. Difference is 0.05. 1.45 minus go aka decrease 1.1, not 1.1. Difference panap 0.45. So we do aka increase ush. How does it affect the panap? It means the panap is not say it's not decrease. Time difference. This is the explanation. Angachibunza mfunzo urikubata something ene so far. N2 wangu aka increase panap.
Yeah, to fill.
N2 wangu aka increase panapo. This value in it is small. This value get a small, this one is small, this one is high, which is okay. But tikatora N2 aka increase iye, tikayeti mtekera panapo. This value in it is small ish instead of big. Ikata small, numerical aperture yangu yakuita small, which is a problem. So how do we solve that problem? We find a compromise. Vice versa. Vice versa. Panapa trikuda, right? Panapa trikuda pa numerical aperture. Pa numerical aperture trikuda numerical aperture is high, right? Trikuda this difference is high. But the difference here is high. Value N2 inofanana small. Simple mental logic, right? Value N2 get a small. Tikatora value N2 is small. Tikayeti pegera panapa. Instead of each is small, each actually big bandwidth director low. That is the explanation. So we need to find a compromise yan N2. Tikasaka compromise N2, it means we have cladding. Because N2 it is the refractive index of cladding. N2 in simple terms, N2 tikamita 1. If N2 is equals to 1, what does that mean? It means we don't have cladding. This is without cladding. Let's have a case like that. Without cladding, what will our numerical aperture be? Numerical aperture, let's say our N1 is equals to 1.45. What will our numerical aperture be like? If this value is equal to 1, it is its least. It means this value, the difference here will be very big. It means our numerical aperture will be very big. For N2 is equals to 1. But if I told that value of N2 to up. This difference, what will it be like? It will be very big. If this difference is big, it means this term here is big. It means bandwidth here is low. Well, I'm tired of repeating this. We have asked.
Yeah,
Thank you very much. We move. I was repeating the same thing. But basically, this is what it is. Right. They're going to bitrate length product. I defined the bitrate length product from my videos. Now I'm just going to talk of this. The bandwidth multiplied by the time difference should be less than 1. This led to a formula. You got it B multiplied by the time difference. Excuse me. Time difference is L N1 over C N1 minus N2 over N2. So this is the time difference here. B multiplied by time difference should be less than 1. Why should it be less than 1? Statement is like I say, how did this statement came about to be? Find out how. Right. If you simplify this, it can lead you to BL is less than N2C over N1 minus N2. BL should be less than N2C over N1 minus N2. This is the definition here, bitrate length. Match the bandwidth. This is bitrate length product. Bitrate length product, BL, should be less than this value. By definition, what is the bitrate length product? Never Google don't. I didn't Google. I want a definition. By definition, what is that? Which fast enough. Bitrate length product. What is that? For an optical fiber, optical cable, a product of a given length of the fiber or the cable can handle specified yada yada yada. What is the bandwidth length? Product is often used in context. It is usually defined as the product length of an optical fiber link and its maximum signal bandwidth. What is the significance? A commonly used figure of merit for communication systems, where B is the bit rate and L is the repeater spacing, the distance after which an optical fiber must be generated to maintain its fidelity. What is the significance of the bit rate length product? Question number 3. Well, I feel it's necessary. What is the significance of the bit rate length product? I'm no longer sure what is the significance of this. Therefore, it's an assignment. What is the significance of the bit rate length product? Definition by equation, do it up. What is the significance of that? All right. More video. What I do remember doing though is the comparison. I managed to compare the BL for cladded and uncladded fiber. I think that's where the significance is there. For an uncladded fiber, BL was less than 0.4, 10 minutes, gigabytes per second meter. This is for uncladded fiber. I made my calculations using N1, N2, C. This one is less than 20 gigabytes per second meter. This is for cladded fiber. What is the difference between these two? Compare these two. Chicha murugona. Chicha murugona. Cable, I want to choose an AP between those two. Cladded or uncladded?
Cladded.
Why? So what that says on those and those to tell. Why? Why I choose a cladded? Because
it per unit time
because it
can be transferred
because it
per
can be
second, not per minute, cannot per time.
per second. Okay. A large number of data, large number of storages, large number of data can be transferred per second. Large number. Large number. A big number of data. A lot of data, right? A lot of data can be transferred per second in a cladded fiber. A huge number of data. Straight up on the chip.
A large amount.
A large amount. Voila. And I always have an excuse. I'm an engineer. It is a large amount. Voila. I know since what wrong, but I couldn't pick out the right way. A large amount of data can be transferred per unit second for a cladded fiber. So I think that's where the answer lies by significance. What is the significance of the bit rate length product? Really paper, but the difference between these two. Can on an uncladded fiber, the amount of data you can transfer per unit second is much less than an uncladded fiber. Right, help me by putting into words amount issue. What is the difference? What is the significance of that BL? Minimizing intermodal dispersion. All right, that is the first thing we do next time, and I think in the video number 9. So we are going to meet on yeah, let me see. Okay, we can discuss meeting later on. Any questions for now? Any questions? Assignment yapo, any 3 questions so far. Let me give you the 4th. Question number 4. Assignment here and them so Monday. Question number 4, and then we on here. A multi-mode, right? New pass. Oh, this is a video. You can replay, yeah? You can replay this. A multi-mode optical fiber. Let me see. Question number 4. Just a minute. Right. A multi-mode optical fiber with core diameter of 50 micrometers. With the core diameter of 50 micrometers is designed to limit intermodal dispersion to 10 nanoseconds per kilometer. What is the numerical aperture of the optical fiber? What is the numerical aperture of the optical fiber? Part 2 of that question. What is the limiting bit rate for a transmission over 10 kilometers at 0.88 micrometers? What is the limiting bit rate? Question number 2. What is the limiting bit rate for transmission over 10 kilometers at 0.88? That is 0.88 micrometers. Use 1.45 for the refractive index of the cladding. The refractive index of the cladding is equal to 1.45. That is the question number 4. Yeah. Snipping 2. Let me do this as well. Any questions? Question when you are replaying the video so that you see the whole picture of the question up. I was just reading out. I think let me do this as well. I'm taking a screenshot. Voila. There is a question. Share this. Voila. There is the question. Marion. Can I zoom that? I don't think so. Question guys. Unfortunately, I don't think I can zoom this. How can I zoom this? Okay, let me save. All right, the can download in the one side zoom, but here I could not zoom it. Where are we in Africa? Here, however, I cannot zoom it. Any questions? Any questions? Do you have any questions? No. Zero fire. Share pictures. Put photos. Voila. Much better, right? Question number 4. We are done. I will decide on that and I will communicate when is our next session. But I'm hoping by next week, Friday, we are done with the 19 videos. Next week, Friday, we are done with the 19 videos so that we find the time, make it a test between Monday and Friday next week. The last week, it will all be revision and maybe something practical, which is not very feasible, but I'll try to squeeze in something practical also to teach. Though one of my problems is modular teaching anyway. Okay, thank you very much. Have a very good morning. I'm out.